So, just a brief introduction on our platform. Today we are taking 16th webinar. Uh, so today's agenda will be, few minutes I'll do for opening remarks and review and impact of our RIT Alumni Advisory Hub RAAH initiatives. Then we will hand it over to Mr. Yogesh Kulkarni for today's webinar, which is on basics of machinery safety. We will follow that with Q&A session for last 15 minutes or so, and then last couple of minutes we'll have concluding remarks. So just in interest of time, I'm just going to quickly talk about RAAH. We all know, so I'm not going to spend a lot of time. But we started this initiative about 2 years ago with a vision to build a globally active alumni network and run sustainable and high impact programs which will help our students. So we are an independent organization of alumni of Rajaram Bapu Institute of Technology, RIT. We started in 2020, as I said, and our vision is based on three pillars: uh, alumni to institution, alumni to students, and alumni to alumni. So what value add we can give? For example, from the institution perspective, we want to help the institute in curriculum formations and organize guest lectures from the industry expert like we are doing it today to seek best practices from global universities and help implement those in RIT. When we talk about alumni to students, uh, major activities or our mission is to mentor students right from the first year in technology and soft skills, to provide them innovative project, internship, work study opportunities, to guide students for job readiness, for pursuing higher education, etc. And for alumni to alumni, to provide business opportunities, to provide a network of alumni. As you all know, we have generated a lot of business leads for our alumni who are owning their own business, and to support entrepreneurs from our network and to give business support. Uh, our uh, our main body, like the RAAH task force, is kind of overseeing all the other forums of RAAH. We have a RAAH business forum, RAAH business innovation forum, through which we are doing a work on e-bicycle. We already done and sold few prototypes of electric bicycle, and now we are looking to expand our operations and generate more leads into that. The RAAH overseas community, which I and Amit support, we are helping the students to for overseas education, helping them learn the soft skills, generate network for them, and RAAH media team and cultural forum, which are our social media activities, presence, and arranging cultural programs for student and alumni. So far, we have uh, done 80 plus meetings pretty much every Saturday in last 2 years. We are meeting, either arranging some webinars or doing some program for the students or doing presentations from business owners and innovators into our alumni community. So every Saturday we are meeting in the same time slot. We have 16 webinars so far. Today is the 16th one, which we did on different topics, right from non-destructive testing, consulting, to today's topic like machine safety, AI, machine learning, lot of topics. These are the visible things for the outsiders, but we also have close to 200 preparatory and review meetings during these last 2 years. So a lot of things goes like in planning sessions like today's session, and review of the session after the session. So a lot of people are putting a lot of efforts to betterment of aluminum college. 2 weeks ago, we had a webinar on career in management consulting for engineers from Mr. Biju George, who is an associate partner with E&Y working out of Canada. It was very, useful, very informative, and very motivating webinar for not only the young students but also for experienced people in our alumni. So, with that brief introduction, I will switch to today's topic. Today, Mr. Yogesh Kulkarni will be talking about basics of machinery safety. Uh, a brief introduction for Mr. Yogesh. He is currently working as head consulting services at Schmersal India Private Limited. He did his Bachelor of BE Electronics from KBP College of Engineering in Satara. After that, he has also completed international certifications in machinery safety, like CMSE certification, Certified Machinery Safety Expert from TUV Nord, Functional Safety Engineer certification from TUV Rheinland. And if I understood, he is one of the very few people probably in India who has both these international certifications. A lot of people have either one of them, but he's one of the few. He has more than 23 years of industry experience. He has been working in the field of machinery safety for, I think, more than 10 years now, handling various machinery safety projects and trainings to national and international customers. He's currently working, as I said, as a head of consulting services in Schmersal, India. This is a 100% fully owned subsidiary of Schmersal Group, Germany, and he's currently responsible for all consulting and engineering activities in machinery safety for Schmersal. Before that, he has worked in different companies in electronics field, in electronic security systems, etc. His hobbies include reading and traveling, and he was telling us a few minutes ago before we started the meeting, he's also working with Vishwakarma Institute Pune to do a 4 days or 4 or 5 days certification course on industrial safety, machine safety for its students. So welcome Yogesh to our forum, and thanks for agreeing to do this for our students and alumni. It is going to be very important, and especially this week is being National Safety Week celebrated in India. So this is opportunity time also. So it is coincidental that the time also matched. So with that brief introduction, without taking much more time, I'll hand over to Mr. Yogesh. Over to you, Yogesh.
Good evening to all. As Mr. Yogesh has introduced me, and I would like to inform you that I am the first CMSE of India, that is Certified Machinery Safety Expert as a first in India, and FSC, that is Functional Safety Engineer. And having a both certification, probably I am the only in the world having a both certification. That is my introduction. So actually this machinery safety, when we call it as a basic, it is a very vast subject. I have a lot of content to show you. Let us try to carry in the short period of time. So one thing when I ask you, who is responsible when you are working on the machine? Who is responsible for your safety? The answer is your safety is your responsibility. So whenever any person is going to work on machine, the responsibility, first responsibility of safety of that person is his responsibility. That is the very first thing. But secondly, whenever we are giving any machine to our operator, then it is the responsibility of end user who is asking them to work on the machine. The responsibility come to him also. But basic thing, your safety is your responsibility. So I would like to tell you what is the meaning of what do you think is a 100% safe machine. So in the consideration, I will say a machine which is disconnected from its all the power sources, that is electrical, pneumatic, or hydraulic. So every power source has been disconnected from the machine. That machine is packed in the wooden box, then wrapped by the plastic wraps and kept in your garden. This is the machine which is 100% safe, that will not give you any harm. But really, we do want this type of machine. The answer is no. We want our machine to not perfectly safe or 100% safe, but we want our machine to produce something in my plant. So when your machine is producing something or functioning, then that machine should be safe. That machine should be safe. This is called as a functional safety. So we have to concentrate on the functional safety of the machine. So official definition of functional safety is the part of overall safety of the system or part equipment that is in functioning, and but it will not give you any type of hazard. So as per the definition of IEC 61508, The challenge of functional safety is in these days is to design the system. That means you have to design the system to prevent the dangerous failure. That means there should not be a failure, but which are dangerous. And or if there is a failure, dangerous failure, then you have to control them. This is the challenge as per 61508. So we'll see what is the hazard. There are some definite words or definitions of the things which are going there. One is a hazard. So definition of hazard. So hazard is a potential source of harm. So anything which will cause you the harm to either man, machine, property, or environment is called as a hazard. So this is the basic definition of hazard. So anything which is going to harm you, that is called hazard. So what are the different types of hazard present in machine or in industry? Those are mechanical hazard, which will cause you a physical injury. Then electrical hazard, all you know, which will cause you electrical shocks or any burns, etc. Chemical hazards is also there. Ergonomic hazards is also there. Then thermal hazard is also there. Then there is a combination of hazard, means there may be some combination of hazards which can cause a several miscellaneous problems in your system. Or vibration hazard, that is also one of the hazard. Noise hazard, so which will cause you the hearing, temporary hearing loss, permanent or temporary. Then there is a radiation hazard which will cause you harm like a skin burns or radiation. So these are the different hazards. So there are some hazards which are going to give you some harm. It's a potential source to your harm. So what is the risk? So risk is the combination of severity of the hazard multiplied by the probability of accessing or occurring of that hazard. So if there is a hazard present, for example, there is a heavy radiation hazard is present, but if you are not accessing, then the risk of that hazard is very less. But if there is a radiation hazard present and probability of accessing of that hazard is more, then that risk is more. So the risk is the severity of hazard multiplied by probability of that hazard. Once we know there is a high risk, there is a risk which is high in my machine. So I want to reduce that risk. So risk reduction or to reduce that hazard, that risk, that can be done by the systematic way. So for the systematic way, you have to follow certain standards. Means you cannot say offload that my machine is safe or there is no any problem in my machine. To confirm that there is really no problem of a machine, I have to design my machine as per the certain steps or standards. Once you design that machine as per the standard, then you can claim that there is no risk. So if you consider there are so many machinery standards are available, and if you consider those standards, if want to standard, then those standards are applicable region wise in the earth. So for internationally, if you consider as a globe, then there are some standards for the machinery safety. Those are starting with IEC or ISO standards. So those are applicable for all over globe. Those are called as an international standard. Then there are some standard for certain region. For example, for Europe. So for Europe, the standard stands from EN. So any standard starting from EN number, that is for applicable for Europe. But as the Europe is a part of our globe, so IEC and ISO standards are applicable also for the European region also. Then there are some countries, specific countries who have some specific standards. For example, Germany. Germany standard starts from DIN. So DIN standards are applicable for the Germany region only or the country. But as Germany is the part of Europe, so EN standards are also applicable for that. And also IEC and ISO standards will be also applicable for the Germany standards. So this is the way where the standards are following. So for the machinery safety, there are more than 850 standards available So those standards are divided into three groups. That is A type standard, B type standard, and C type standard. So normally A type standards are for the which are applicable for all type of machinery. So it will be applicable. It is a general consideration and it will be applicable for all types of machine. Then B type standard is divided into B1 and B2. So for B1 standard, it will applicable for a safety aspect of a special things. That means a safety distance or a safety related parts of control system, etc. That will be applicable. So those are the B1 standard, and B2 standard are specifically for product. That means emergency stop, light curtain, or whatever the product you are using, those standards are called as an B2 type standard. Then there are the C type standards are also available. So C type standards are specifically for special machine, where some machines are defined and the special standards are available. That is called as C type standard. For example, press machine or any robotic system standards available for robots are called as a C type standard. So C type standards are also available. So currently, if you see in India, so all this standard structure and everything has been started from Europe. So in Europe, it has been defined all these standard structures and how you have to declare your machine as a safe. So these are originated from Europe, and then it is been transported for in the IEC and ISO. So ISO standard. So what is the current situation in India? So in India, actually there is a requirement, there is a law is there that is called factory rule or a factory rule that is situate means it has been there from 1948. That is Factory Act. So as per the Factory Act, your machine should be safe. So as per the India requirement, your machine should be safe and there should not be any harm or any injury from your machine to your worker who is working. So that Factory Act is already existing in India. But that Factory Act tells only your machine should be safe, but it doesn't give you the way how you can declare that your machine is safe. That is the biggest issue. So unless in India, unless until there is an accident occur, your machine is safe. Means if you are using any machine in your factory, unless until there is some accident or some mishaps happens, then you can call that your machine is safe. But in Europe, they have informed exactly how you can design your machine that can be safe. So those all the way of designing of the machine that is been stepwise informed, and they have given the information that if you follow this standard, then you can call your machine as safe and there is no possibility of accident. So that structure is there, but in India, as per the Factory Act 1948, it is required that your machine should be safe. But currently, what we are doing in India, we are adopting some ISO standards by the BIS. So in Indian industry right now, we have adopted many standards from ISO, which are actually driven from European Union. So those standard has been adopted and now it is going to be imposed in India. So the Indian standard are going to be informed as a IS. So those standards has been adopted. So this is the list of some of the standard. So at the current situation, 32 ISO standard has been adopted by the BIS, that is Bureau of Indian Standards, and it is been implemented. It is going to be implemented in India. So this is the list of those standards, ISO standards, which has been transported or adopted by the government of India. So we'll see some of the, so we know, if we know the international standard or EN standard, what they are going to do, the same standards has been adopted by the government of India. So it is in near future. Actually, it was means decided that this is going to be done in the 2018, but because of this corona and all other pandemic situation, it has been delayed, and still now we don't know at what time it is going to be there implemented in India, but we hope that it can come at any time, any point of time. So if you know the basics, main standards while doing or while dealing with the machinery safety, then that will be beneficial once it is being transported. So there is a basic standard ISO 12100. So this is the ISO 12100. It is adopted by in the BIS as a IS 16819 2018. So this standard gives the general principle of design and risk assessment and risk reduction. So as per this standard means it's a very simple thing. You want to do your machine safe. So first thing you want to know what are the risks present in my machine. If I know there are 10 risks present in my machine, then I can work on that 10 risks and I will try to reduce those risks. And then I can say, now I don't have any risk in my machine, so my machine is safe. But saying only my machine is safe, that is not sufficient, or that may not be sufficient. For that, ISO 12100 standard gives you the stepwise process how you can reduce your machine, or how you can reduce the risk, or how you can evaluate the risk. So this is the chart or flow chart. You can see where this ISO 12100 gives. If you do the risk assessment, because it is very simple that you can say my machine is safe, but how you can prove? That is the way you have to do the risk assessment. Once you do the risk assessment, then you can say my machine has a low risk or high risk or medium risk, whatever it is. So to follow or find out what is the risk, there is a stepwise information is given. So this is the flow chart. That is first is determine the risk limits of the machine, then hazard identification, risk estimation, then risk evaluation, then whether those risks are acceptable or not. Then you have to inform the risk reduction measures also. So risk assessment doesn't only give the checklist that these are the high risk in my machine, but it required to give the information how you can reduce that particular risk. And once you do the risk reduction measure, then you have to go again and follow this. Once you complete that risk as acceptable, then you can end. So this part is called as a risk analysis. So in this chart, it's a harmonized standard. So first, what is the machine limit? Machine limit means whenever you are using any machine in any particular condition. Limit, in this case, the limit means in the condition where you are using the machine. I'm just giving you one example. Suppose I have a grinding machine. That grinding machine, if you ask how is the risk to use the grinding machine, if I know only the grinding machine, then I may call that is the very high risk because I may have some abrasion hazard or something like that. And somebody says there is a very low risk. So we cannot determine what is exactly the risk related to the grinding machine. But if I define that grinding machine is going to use in the factory of Schmersal, okay, and that is going to be operated by the regular operator of the Schmersal, then what is the risk of having a grinding machine in my plant? In that case, that risk will be less or low risk. Okay, but if you say the same grinding machine, I'm going to put it in the public place like a railway station. In that case, having the grinding machine in the public place, the risk is very high because anybody can access or anything can happen with that type of machine. In the first case, when it is going to be used in the Schmersal factory, it is means understood that it is going to operated in the industrial environment, then it is going to be operated by the trained people. So using that grinding machine in Schmersal factory, risk is low, but using the same machine in the public place, risk is high. So where you are going to use those kind of machine, that is been defined by the limits of machine. Okay, so who is going to operate, who is going to work, how you are going to use it, where it is going to be situated, all those things are informed in the limits of machine. Then you have to find out the hazard. What are the hazard? So we have seen there are a lot of hazard, electrical hazard or mechanical hazard, all those type of hazards are there. So you have to find out each and every hazard. Once you find the hazard, then you have to do the risk estimation. So for the risk, I cannot say it's a high, low or something because it's a relative term. So we have to give some numbers to that particular risk. So finding out the risk estimation, there is a one method that is called HRN, that is hazard rating number. So for HRN, we have seen the risk is a function of severity and probability of occurrence. And the probability of occurrence can be divided into again three different sectors to have a perfect judgment of the risk. That is exposure of a person to the hazard, occurrence of a hazardous event, and the possibility of avoiding or limiting that particular harm. So from these three parameters, we'll come to know the what is the probability of occurrence of the hazard. So for that, there is one defined method is there. So for each and every event, we have given some numbers to each and every event. For example, if that first is the P, that is probability of hazard event or presenting or the person being exposed to that hazard. If it is almost impossible, highly unlikely, occasionally or possible but unusual, possible, exist. For that, we have given some, they have given some numbers. So we have to select what is exactly the situation when you are accessing that particular risk. Then that is FE, the frequency of person being exposed to hazard, maybe weekly, monthly, like daily, hourly, or permanently. From this event, you have to choose the number given assigned to that particular. Then MPL, that is maximum possible damage of injury, that is the severity of hazard. So if it is a major bone break, then you have to select certain number. If it is a death or a fatal incident, then you have to select the number. And the number of person exposed to that particular risk. So if it is 1 to 2%, then you can select 1, 3 to 7%, you have to select 2. So once you select all those parameters, then you have to just multiply those things to get some number. That is HRN is equal to PE into FE into MPL into NP. So you will get some value for that particular risk. This is the process of risk estimation. Once you get the risk estimation, then you have to evaluate that risk. You have got some number from the risk assessment, then you will evaluate that. So if it is HRN is less than 10, then it is permissible or very low risk. If it is 10 to 50, then it is low but significant. If it is 50 to 500, then it is high but considerable. And if it is less greater than 500, that is high or prohibited. So like that, you are evaluating the risk. So what is the meaning of negligible risk is that there is a risk present, but it is negligible, which can be accepted. So you don't need to make some risk reduction measure, but you have to inform to your operator that there is a risk present. If it is low to high risk, then you have to do some plan to reduce that risk to acceptable level, and you have to do some measures in the coming time. If it is very high risk or extreme risk, then you have to act upon it very immediately and you have to reduce that risk to acceptable level. And if it is unacceptable risk, then you have to stop the machine, don't operate the machine. You have to change the design of the machine so that that risk can be reduced to acceptable level. So now we come to know there is a risk which is high, low, or medium, whatever it is. By this chart, then you have to reduce the risk reduction process. So you have to follow certain risk reduction process. Then if it is protective measures are required, which are controlled by some control system, electronic control system, then there is a standard that is called ISO 13849. You have to follow those standard, or else if it is a mechanical risk reduction, then you can go there, and you have to find out whether while doing the risk reduction in your machine, whether you have incorporated some new risk. If it is not there, then you can check whether this is risk reduction is okay or not. If it is, there is new hazard is present. For example, I'm just giving you one example that there is a risk that I'm going to put my hand in front of my machine. So to prevent that, I am using one operable door which is pneumatically operated. But when I use a pneumatical door which is pneumatically operated, which will close and then only my machine will start. In that case, I'm introducing one more hazard that my hand can get cramp in between the door, moving door. So I am introducing a new hazard. So this comes in this sessions, whether I am introducing a new hazard, because that hazard was not present initially when I'm assessing a risk, but after risk reduction measures has been incorporated, I have introduced one new hazard. So if that new hazard is there, then I have to go and do all the risk reduction again. So in 12100, risk reduction, for doing a risk reduction, it is giving a stepwise approach. So you have to follow a 3-step approach. First is called as a direct safety, that is prevention of danger. So just for example, there are 2 rollers rotating in opposite direction. If those rollers are very near, then there is a hazard present. I will entangle my hand in between those rollers. That is the hazard if I access it. So the solution or direct safety solution is that I will increase the distance between 2 rollers so that hand entanglement hazard is eliminated. So this is called the prevention of danger. So there is no hazard present because I have increased the distance of 2 rollers like this. So there won't be entanglement of my hand hazard is not present. So this is called as a direct safety. Many cases it is not possible because I want 2 rollers to be very close to do my process or whatever the process I am doing in my machine. In that case, you can reduce your hazard, which is called indirect safety. That is called a protection against danger. That means I am going to put some guard here so that I am not able to access this entanglement point, so that I will not able to put my hand in between these 2 rollers because of this guard. This is called as an indirect safety, or it is a protection against the danger. So this is the second step. After doing a second step, there is a third step, which is called indicative safety. Means you will try for first a direct safety, that means eliminate the hazard or prevention of danger. Then if it is not possible, then you will try for indirect safety. And once indirect safety is done, your risk is reduced to acceptable level. But here again, you give an indicative safety. Indicative safety means you will have some procedure or SOP, that is safe operating procedure, or you will give some stickers or some warning signs, training to the people. So if means you should not remove this guard from the machine and then only you will access. All those things will come as an indicative safety. So this is the 3-stage risk reduction mentioned in ISO 12100, and you have to always follow from top to bottom. Means it is very easy to put a board that don't put your hand, otherwise you will lose your hand. That type of board we see in our normal lifts, in our domestic lifts also. But this is not a perfect safety solution as per ISO 12100. First thing, you have to try for direct safety. If it is not possible, then you go for indirect safety. And after indirect safety, whatever the risk reduction has done, up to acceptable level, then only you have to give for indicative safety. So in this graph, you can see this is the increasable risk. Then it is accepted that you have to reduce your risk up to tolerable risk. But it is expected that you should not stop at this point, but you have to go some more further. So that up to this point, so that after that you will got the residual risk. This is called residual risk. Means risk is present, but you can accept that risk. So that is called as an residual risk. So this is the risk assessment report what we as a Schmersal provided for our customer, which include everything in the one page, that what is the hazard, what is the type of, means what is the risk level of that hazard, then what are the risk reduction measure required, everything we are providing as a Schmersal point of target. So if you see the 3-step risk reduction method, first thing is the direct safety. So in general, the direct safety can be implemented during the design of the machine. When you are designing the machine, you can reduce all those type of risks. But once your machine has been built and it is being used in the plant, that time a possibility of direct safety in your machine is not possible. So you have to use indirect safety. That means prevention of hazard. So now we are considering the machine is already been there in your plant, and which we want to make a safe. So we have to use a second stage of a risk reduction, that is prevention of hazard or indirect safety. So we can call this as a protective measure. So in case of protective measure, you can have a two type of guarding. One is called as a hard guarding, which is a physical guard, which will prevent you or operator to access the machine. And there is an open guarding also. So physical guard means you are using some physical guard which is there in your machine. So when you use the physical guard which is operable or movable, means you can open the door and go inside the machine. In that case, that has to be interlocked with some safety system. Or you can use this type of fixed guard, which has been fixed by fasteners, maybe on welding permanently, means connected on the machine. So these are called as an movable guard and fixed guard. Then in case of open guarding, that is AOPD, that is light curtain. That means there will be a light curtain present in front of your machine, which will allow you to cross that light curtain. But when you cross it, it will give the signal to your control system to stop. So this is AOPD, that is active opto protective devices. Then you can use some safety mats or safety edges. So these are the devices which are used to have some means prevent some floor size of your machine. So anybody is entering in that particular area, then your machine will be stopped. Or you can use a two-hand control. So two-hand control is the two switches which has to be pressed simultaneously at the same time. Then only your machine can move. That means your operator hands will be engaged. So he will not able to put, or he will not put his hand inside the moving machine. Or you can use some enable switches. So these are some open guarding type of switches. So when we are deciding as an engineer to adopt some protective equipments or protective measures, then for each protective measure, there are international EN as well as Indian standards available. So you have to follow those standards when you are adopting any protective measures. So we'll see some major standard EN ISO 14120 that is been adopted as IS 16811. So this is the standard for the guards. So when you are using any guards on your machine, you have to follow certain standard that is called ISO 14120. So what is implies is that when you are using any guards which can be removed, so it has to be fixed by the fasteners. So when you are using a fasteners, that fastener should be able to open by the special tool. This is the special requirement from this standard. That means you have to use a fasteners like this, some different shapes. You cannot use the chisel head type of a screws or wing nuts to fix the guards on your machine. That is not allowed as per this standard. So you have to use fasteners which can be opened by the special tool. That is the basic requirement from ISO 14120. Then there is a standard that is called ISO 13857. This is also been adopted by BIS. So this standard gives you the information about when you are installing the guard on your machine, you should not be able to access it. So for example, there is a opening in your guard. So this gives how should be the opening and what should be the safety distance. I will give you one example. In your home, we are using a table fan, and table fan is having one cover. So this cover is preventing us to access the rotating blade. If you access that rotating blade, then your finger or hand can get cut. So there is a cover given, but that cover is of mesh. Suppose that mesh size is more. So if you are able to put your finger from that opening in the mesh, and if you are able to reach to your fan blade, rotating blade, then you will get there is a high risk. So to prevent that, what should be the size of the mesh, and if the size of the mesh is what, then what should be the distance of the rotating blade and the mesh that is been defined in this particular standard. Means, for example, if your mesh size is 4 mm and a slot is the 2 mm, then your safety distance should be more than 4 mm. Like that standard, it is been given that what should be the mesh size. Same thing when you are installing any guard in front of any hazard, then what should be the distance? So this is the hazardous point from, and this is the guard installed in front of that particular hazard. Then person standing in front of him, if it is accessible, then it is not allowed. So in this case, what you have to do, either you have to increase the size or height of this guard so that person cannot reach here, or you have to make the distance away. So all those things, there is one table given in this particular standard. What would be the height of your guard, then what should be the safety distance. Everything is you can calculate while designing your machine from this chart. So this is given in the ISO 13857. So this standard is also adopted right now by BIS. Or if there is a gap, suppose there is a gap of 120 mm, then the distance from that particular guard to your hazard point should be more than 850 mm. If it is less than 850 mm, then within this gap you can touch to that particular hazardous point. So this type of calculation is been given. Then there is another standard that is called ISO 13855. This gives, suppose if you give the stop command to your machine, and if you are going to access that machine, but a stopping time of that machine is more, in that case you can access and you can have some hazard. You can access some hazard. So for that, what is the what you can say means response time of a human body that is been defined in this standard. So there is a formula that is called S is equal to KT plus C, where S is the safety distance, K is the moving point or reaction time of the human person, T is the stopping time of the person, and C is the constant. So this is the formula given by this. So you have to put your safety measures away at a sufficient safe distance. After that, you give the stop command. Machine should stop and you should not be able to reach to that particular thing. So that has been given by this standard 13855. So if you are this standard is particularly applicable for the light curtain. That is, if you are using the light curtain, If the resolution of the light curtain is 14 mm, then it is called as a finger protection. If it is a 30 mm, then it is called as a hand protection. And if it is 50 to 500 mm, then it is called as a body protection. Then when you are designing your circuit, means I'm designing one of my machine. If I open the door, my machine will be stopped so that I will not able to access a particular thing. This is called as safety related parts of your control system. So for that, there is a special standard available. That is called as an ISO 13849. So this is the stepwise approach for risk assessment and doing your safety control system strength. I will give you one example. In our car, there is a brake. So brake is nothing but a safety control system. So whenever I am applying the brake in my car, it is expected that it should apply and stop my car. This is called a safety function. The same way in my machine, our machine, a safety control system is used. So whenever I call the safety function, my machine should stop. Suppose my brake system is not strong. I am using in car, suppose a very weak system in the brake. Then if I apply the brake, there is a fault in my brake system. So brake will not apply, my car will not stop. So I am definitely going to claim the accident. So my safety control system, which is a brake system in my car, should be strong enough. Whenever it is being called, it has to perform. Okay, in the same line, in the control system of safety control system of a machine, whenever I demand that should act, that machine should stop. We cannot say that because there is a cable or a wire connected from my pedal to my brake system that has been broken. So when I apply the brake in my car, it is not applied, so I claim the accident. We cannot say. We have to design our safety control system very strong, or the strength of the control system should be strong enough so that whenever there is a demand, it will give the result. So same thing is given by the safety control system in our machine. So that safety control system is called as a safety related parts of our control system, and the strength of safety control system is determined as a performance level. So you can see in this graph, there are performance levels from A, B, C, D, and E. So A is the less strong performance level and E is the highest performance level. So whenever we are designing the machine safety control system, we have to first find out what should be the strength of our control system should be. So this can be determined by this graph. So this is determined by the three parameters, that S, F, and P. S is the severity of injury, F is the frequency of exposure, and P is the possibility of avoiding that particular hazard. So if S is H2, that means a severe injury. This is H2. Frequency F is the means less frequency, or F2 is the high frequency. Then P is possible under certain condition, or to avoid scarcely impossible. So you have to start it from this point. Suppose there is a press machine where if I put my hand can get crushed. So in this case, the severity is H2 because it's a severe injury. So I have to come to here. Then what is the frequency? Suppose I am doing the manual loading and unloading, means every cycle I am putting my hand in front of press. Then it is F2, that is frequent. Okay, and whether it is possible to avoid. So my operator is very trained operator. There is no accident occur. So you can go to F1.
Hey, just a quick time check. We are 15 minutes into the session, but if everyone is okay and you are okay, maybe we can extend by 10-15 minutes. This is going on really well. So I'll leave it to you and people, if we can extend, if we have permission to extend from the attendees also another 10 to 15 minutes. So we have 10 minutes from the original scheduled time, and maybe we can extend another 10-15 minutes if that's okay with everyone. Also, we have some technical issues with the chat. So if you have any questions, you can raise your hand or you can unmute and ask the questions. So is that okay with you, Mr. Yogesh? Like we can extend by another 10-15 minutes?
No, I can take more than 10-15 minutes right now.
Yeah,
Means
no,
I'm not having clock in front of me.
yeah, okay. So we have 10 minutes anyway in the session. So if we extend by another 10-15 minutes, it will be additional like about 25 minutes or so.
I don't have any problem.
Okay, thank you. All right.
Okay, so from this graph, you can go and you can find what should be the performance level or strength of my safety control system would be. So in this case, it may be performance level C or performance level D. So once you know what is the performance level required, suppose I have required a performance level D. In that case, there are the certain parameters we have to find out. First is called as an architecture, how you are designing your control system, that is architecture. Then there is a one parameter that is called MTTFD, that is a mean time to dangerous failure. That means the quality of your components used in your control system should be high so that it don't fail in the dangerous failure. Then there is one parameter that is called diagnostic coverage. So diagnostic coverage is nothing but checking the control system. Means you are designing some control system, but if there is any fault, then you should get some intimation that there is a fault in our control system. And then you have to consider a common cause failure. That means there may be some external causes like environment, temperature or whatever. So considering all those things, you have to design your safety control system. Then you will come to know what is the things. So this is the way of your control system. So this is called a category, that is selection of your control category. So if you are using a standard switches and if it is been monitored by the standard controller, and if you are stopping the motor from this controller, then this is called as a category B. Then if you are using instead of standard switch, a safety switch, we'll see what is the difference in standard and safety switch in next parameter. Then this is called as a category 1. Then there is a category 2 where you can check the status of input and output everything and then deciding your factor. Then this is called as a category 2. In category 3, you are using a dual channel, that is called redundancy. Here at output also there will be a dual channel, that is also redundant. This is called a category 3. Then it is the highest category where that is called as a category 4. So these are the category. So depending upon category, what you are doing the wiring, diagnostic coverage, and what is the MTTFD value, you can determine what is the performance level received from your control system or safety related parts of your control system. Now we'll see some limit switches and safety switches. So we have seen we have to use a safety component in our safety control system. So first of all, what is the difference or what is the new in the safety component and the normal component? If you consider this, in that case, functionally safety component and normal component are same with a function. For example, you are using a proximity switch like this to check whether my door is closed or not. And if you are using a safety component like this to check my door is closed or not. So when you open the door, you will get the machine stop condition from both of them. So functionally, both the components are same. But when you see the standard component and safety component, so safety component is having these three parameters. So one is called as a redundancy, second parameter is called as self-monitoring, and third parameter is called a fail-safe. So we'll see one by one what is this redundancy. So redundancy is nothing but a dual channel. So there will be a two channels present. So if one channel fail, second channel will be there to take care of the safety function. Means your safety function will never fail. Then self-monitoring means it will always check the condition of your control system. Is there any fault? Is there any problem? Is there any wiring fault? Whatever. And if there is any fault find, then that will be informed to your control system so that it will take a action. This is called as self-checking or self-monitoring. Then it called as a fail-safe. So in our world, we cannot give a guarantee that my component will never fail. For example, I have one component which is rated for 24 volt DC voltage, and by mistake I given the voltage of 230 volt, then it is going to burn and it is going to fail. So there is nothing can be guaranteed in this universe that it cannot fail. But when you call it as safety component, then it will be called as a fail safe. That means if it fail, then it will always fail in the safe condition. So this is the one of the quality. So what does this means? We have seen the high MTTFD value, that is mean time to failure dangerously. So that value is very high. So we can give a guarantee when I'm using a safety component. If it fails, it will always fail into safe condition. Means a positive break. For example, positive break means what? Whenever you want to give a stop command, means you have to disconnect the supply, means you have to make a NO contact, that is normally open contact is required. So NO function is not dependent on any spring or any other things, but it will be opening of your contact is depending on your physical force. This is called as a positive break. So any component which is having a fail-safe function will have a symbol like this. If this symbol is there, then you can find this is a positive break contact. So these are some of the components which are used as a safety component or safety switches in the market. So these are non-contact type of safety switches which don't require a positive break. So this is the tactile devices that we have discussed. That means it is used to have some protection of area. If I stand in this area, then I will give a stop command to my machine, and this is called safety mat. Or you can use a safety edge like this. You might have seen this type of equipment in the closing door of a metros or any lift. Also, they are using this type of safety edges. These are the light curtains which will be used for protecting some area from where you cannot access. Then you need a safety relay. So what is a safety relay? Safety relays are controls are it is having a functionality of self-checking, redundancy, and positive guided safety contact. And finally, you will have a control reliability. So control reliability means whenever you demand a safety function that I want to stop the machine, in any case, my machine should stop. If there is any fault in my control system or any wiring fault is there in my machine, then also machine should stop. So this is called a control reliability. So this has been achieved by self-monitoring feature and redundancy, what we have seen. So this is a typical safety control relay circuit. So you will have a dual channel at the input, dual channel at the control, dual channel at the output, and dual channel at the output. So this is a safety relay is always a control reliable thing. So here I finish my safety training. Now I just want to give you some glimpses of what the Schmersal India is. So this is the bird eye view of the Schmersal India. We have a plant, manufacturing plant in Rheinland, MIDC in Pune. So Schmersal India is 100% subsidiary of Schmersal GmbH from Germany. And Schmersal India is the only company who is having a manufacturing plant of a safety component in India. So no our competitor in the India has a manufacturing plant in India. So for Schmersal, we have a 41,000 customers. We are working on systems and solutions. We have more than 16,000 products. We are working in Industry 4.0. We have experience more than 75 years, having 18,500 employees, and we are manufacturing site, 7 manufacturing sites all over globe, and the one goal, that is together with our customer partners, we are turning workplace in the safer place. So this is the overview of the presence of the Schmersal in the globe. So these are the 3 plants in Germany, 1 plant in Brazil, 1 plant in China, and 1 plant in Rheinland, Pune. And we are covering all over globe by our subsidiaries and sales partners. So these are the safety components which has been produced by Schmersal for all types of industry application. So we have one division that is called Technicum. So this division is specially for it's a product neutral service division, from where we are giving different type of services as academy, where we give seminars, customer training, or in-house training. Then we'll do the consulting business of risk assessment, CE assessment, lockout, tagout, etc. Then we'll do the engineering also, means physically working on your machine, and we'll do the integration of your machine for the safety. So these are the focus areas of a Schmersal India, that is CE marking, risk assessment, robot safety, machine guarding, LOTO, that is lockout, tagout, and safety implementation. So I put my hands here. It was a very short time. There is a very lot of things which I can explain you, but if you have any specific question, you can go ahead with.
So thanks, Yogesh, for taking time. I know you had to probably hurry through some of your material in interest of time, but it was very useful. So we have, again, as I said, we are not able to enable the chat. So if anyone has any questions, you can unmute yourself and ask the question. And I'll take over the screen share.
Hello.
Yes.
Hello, Yogesh sir. Thank you for such a wonderful session. I have one query related to high MTTFD for the dangerous MTTF. So, whether can I say, suppose the life cycle, or what can I say, life cycle of my machinery is around 10 years, and sensors I have been using is giving me more than 10 years. So it would qualify for the high MTTFD.
No, actually, I have not gone in detail about the MTTFD. First thing, there are 2 types of failures. Okay, one is a normal failure, another is a dangerous failure.
Okay.
Okay, so normal failures are not considered in our safety scenario. Okay, I'll just give one example. Suppose if my power fails, power is off, so my machine is stopping. Okay, so this is the normal failure for me, which I will not consider for the safety evaluation. Okay, but in my control system, suppose my controller fails and I give a stopping command to my controller or my machine, but it is not stopping. This is called a dangerous failure.
Dangerous situation, yeah.
So there are 2 types of failures present in your any system. One is a normal failure. Normal failures are accepted. as per the safety. But the dangerous failure we have to call, we have to consider. So dangerous failure probability is being defined by MTTFD.
Okay.
Mean time to
So
fail.
it might happen that supplier has given MTTF for the sensor, but
So,
MTTFD has to be derived from our system.
Normally for any electronic component just like a PLC or any light cutter, everything. So they give the MTTFD value by the manufacturer. Okay. Manufacturer will provide you the value of MTTFD. But there are the component which are electromechanical component, like a switches. Okay. In that case, the manufacturer will give the value that is called B10D. B10D.
Okay.
And from B10D value, you have to calculate MTTFD. Actually, that slide was there, but I just pass away because of the time constraint. Means suppose you have one mechanical switch, for example. Okay. So that mechanical switch going to operate once a week. In that case, a possibility of failure is 30 years. I'm just giving you an example.
Okay.
But if that same mechanical switch, if it is going to operate once a minute, then possibility of failure will not be 30 years. It may be 20 years.
Yes.
Correct. So for mechanical switches or electromechanical contacts, manufacturer will give a B10D value, and depending upon number of operations, you have to calculate MTTFD. That formula is given in the standard.
Okay, sir. Noted, sir. Thank you.
So
the question is clear. Yes.
Actually, because of a time constraint, I'm not able to give in all those things in detail, but it's okay. Means that's all we can do it.
Yes, sir. Thank you.
Okay.
So any other questions, comments? Otherwise, we can conclude today's session. So I'll hand it over to Abha.
I don't think I have taken a lot of time.
No. I know you had to probably hide a little bit, but yeah.
Yeah. Thank you, Yogesh ji. It was indeed our pleasure to have you on our platform, and I must thank our Yogesh Hasabnis, for bringing you there.
I'm also yours.
I know. So it's really a great talk to end Safety Week, which got started from, I think, 4th of March. To be very frank, these are the subjects. When Yogesh proposed this session, I immediately reacted to that. These are some of the subjects which are really not given due importance in Indian context. And to be very frank, the amount of importance which the rest of the world gives for very simple, they look very simple, but they are very important. Someone can lose his say finger, hand, or anything, and the worst case, the life. So to be very frank, the way you looked at from the risk management perspective, I really like that, because I am a risk professional. I was in risk management, so I do understand importance of that. We have lots of young engineers, professionals who are there on our group, and especially from startup side and product design side. I will very specifically request them to please look at these specific aspects when you are either designing it or you are operating the machines, because safety for all who work around us, who work with us, is of utmost importance. Uh, I'll like to thank all the attendees who were there today.
Actually,
And
I want to make one comment on this.
yeah, please.
Actually, in India, right now, I'm in the verge to give the information to our customer that safety is not a rocket science. Okay, it is only is the view how you can see those things. That is what the information I'm giving in the industry right now. Because I have seen in my professional career that when I saw it is a safety, then people scare. It is something different you are going to tell me. But it is not a different things, or it's not a rocket science. You have to follow the simple steps and you can easily achieve the required safety level. That is what the promotion, what I'm not saying a promotion, but that is what the information I'm trying to give in right now in industry in India. So safety is nothing but your view of the things. Means when
It should be way of life, because
yes,
I think just
means safety is
wearing
always
a
there.
helmet or
Only thing
putting,
you have to make one switch on in your mind.
yeah. So just I was saying just wearing helmet while driving bike, and then pulling your car seat belt. These
Yeah,
are very
car seat belt is
important
a very good
behaviors.
example of the safety.
Yeah, because otherwise,
It's not a
what you are
rocket
going to do?
science. It's a very, very basic thing. If you
Yeah,
follow those things, it's not a big thing that you have to change. Because in industry, when I go and talk to any management people, then they thought if I want to implement safety means I have to spend a lot of money or a lot of efforts on that. But once they understand this is not a rocket science or a different thing, it's a very routine things. Means while selecting a component, if you use a safety component, then you will have a high MTTFD that it is not going to fail. If you wire the same things, then you can achieve a more safety in this.
absolutely.
That is not known to the industry. That's why they are not following. But I'm trying to make them aware, and means I'm really happy that a lot of industries are following me also right now in India.
Great. So once again, thank you so much, everyone, and I hope this session was helpful for all of you. Once again, thank you, Yogesh Hasubnis, the entire task force team, who really works very hard behind making these sessions happen. Look forward to meet all of you. I think maybe same time, same day, next Saturday. Thank you and good night. Thank you.
Thank you.